I'm about to show you the 3 AWS projects that will get you hired as a cloud engineer, even if you have zero professional experience. After helping 300 plus students land cloud engineer roles paying 120 to 150K, I've learned that employers don't care about your certifications or your degree. They care about one thing. Can you actually do the job? That's why these 3 projects are designed to prove you can handle real production work. So by the end of this video, you'll know exactly what to build, how to build it, and how to present it in an interview so hiring managers see you as the obvious choice. Let me explain why these 3 projects are the ones that actually get people hired. Because I made the same mistake most IT professionals make. I wasted over $70,000 on a degree and certifications thinking that would unlock the cloud engineer world for me. And after all that, I still could not get hired. The turning point for me happened in an interview where I profoundly mentioned my certifications, and the hiring manager literally stopped me and said, "Tile, certifications don't tell me if you can do the job." And that's when it hit me. Because a week later, I watched someone with no degree and half my experience get hired for the same role I was chasing simply because he had demonstrable projects. That's when it clicked. Documentation gets you in the room, but projects gets you the job. Once I built actual AWS projects that mirrored real production environments, everything changed. Recruiters started reaching out. Interviews got easier for me, and offer letters started showing up because I wasn't just talking about knowledge anymore. I was demonstrating competence. I want to show you the exact framework behind these 3 projects that will do this for you. These aren't just random tutorials. Each one is intentionally designed to prove a specific capability that every cloud engineer job requires. Project 1 proves you understand core AWS architecture, VPC, EC2, load balancing, auto scaling, RDS, monitoring, the fundamentals of production infrastructure. And Project 2 proves you can automate infrastructure using industry standard infrastructure as code tool. When employers see Terraform, modules, variables, version control, they instantly know you can work on a team. And Project 3 proves you understand DevOps workflow and deployment pipelines, how companies actually ship code 20, 50, even 100 times per day. When you combine these 3, you're demonstrating the full life cycle of a cloud engineer. Design it, deploy it, automate it, and then ship updates safely. This is why my students get hired without prior experience, because these projects, they show hiring managers you don't need to train this person. They already act and think like an engineer. That's the advantage you're about to build for yourself. So let's start with Project 1, the one that proves you understand real AWS architecture. Most beginners build little single EC2 projects that fall apart the moment traffic increases or a server crashes. That's not engineering, that's a school project. What we're building here is different. This project will demonstrate high availability, tolerance, and scalability, the exact language employers use in job descriptions. This is the project that made everything click for me. When I finally learned how to design infrastructure that could survive an outage, handle traffic spikes, and recover automatically, that's when I stopped feeling like a help desk guy pretending to understand AWS and started thinking like an engineer. We began by creating a VPC with public and private subnets across multiple availability zones. This ensures your application stays online even if an entire data center goes down, something every hiring manager wants to hear. Then we launch our EC2 instances behind an application load balancer. This allows traffic to route intelligently and removes unhealthy servers automatically. Next, we implement auto scaling. This is where you prove you understand production, cost efficiency, and elasticity. Scale out at 70% CPU utilization, scale in at 40% CPU utilization. This alone can reduce infrastructure costs by up to 40% compared to running fixed capacity 24/7. We deploy an RDS instance in a private subnet with multi-AZ enabled, so failover happens automatically without downtime. S3 handles static content, utilizing CloudWatch for monitoring purposes, dashboards, alarms, and automated responses so issues get caught before customers experience them. Now, I'm going to tell you the truth. The first time I built this architecture, I broke everything. My auto-scaling group kept terminating instances, my load balancer health checks kept failing, and I remember sitting there at 2 a.m. thinking, if I can't fix this, I'm not cut out for cloud. But that debugging session taught me more than any certification ever did. I actually got real world experience. I learned how to read logs, interpret CloudWatch metrics, follow the data, and solve problems like a real engineer. That moment changed my confidence forever. And once you build this, it'll do the same thing for you. By the time you finish this project, you're no longer another person with AWS on their resume. You're someone who can design, deploy, troubleshoot, and optimize production grade infrastructure. This is what separates candidates who get interviews from candidates who get offers. Now, let's move into project 2. And this is where you separate yourself from 90% of candidates, because anybody can click a button inside the AWS console. This does not make you an engineer. It makes you a technician. Companies today don't want technicians. They want engineers who can think in systems, codify infrastructure, and deploy environments consistently without human error. Terraform is the skill that took my career from "I hope they hire me" to recruiters chasing me for roles paying $150, $180, even $200K. Once you understand infrastructure as code, you're no longer competing with entry-level applicants. You're operating at the level companies pay real money for. We start by creating a clean Terraform project structure. Variables.tf file for your variables, outputs.tf file to export key values. This immediately signals you understand industry standards. Then we convert everything from project 1, the VPC, the subnets, the route tables, application load balancer, auto scaling group, EC2, RDS, security groups, into Terraform code. Now you've taken a 4-hour manual deployment and reduced it to an 8-minute automated build that works the same way every single time. We run Terraform plan to show the execution blueprint, something every cloud engineer uses in real production workflows. Then Terraform apply automatically provision the entire stack while tracking every change in state. This is the difference between hobby projects and real engineer infrastructure. Terraform is the shortcut to competence. It forces you to understand architecture at a deeper level than clicking ever will. We finish by writing a clear professional README that documents what the code does, how to deploy it, architecture diagrams, environment variables, and prerequisites, and troubleshooting steps. This alone makes your GitHub looks like something a mid-level engineer would produce. When hiring managers see Terraform on your resume and they see real code in your GitHub, they instantly know you're not a beginner. You're someone who can contribute to real infrastructure on day one. And that's exactly what companies pay for. By the way, you're an IT professional stuck making 40 to 60K in help desk and want to transition into a 120 to 150 cloud engineer role. I run an 8-week program where we build these exact projects together with live coaching, mentorship, and a guarantee you'll land a job within 12 months or you get your money back. Plus, if you don't make 10 times your investment after getting the job, you get your money back, no questions asked. Click the first link in the description to learn more, but first, let's get back to the video. Let's talk about project 3, the one that proves you understand how modern engineering teams actually ship software. Because here's the truth. Legacy IT teams deploy once a month and pray nothing breaks. Modern DevOps teams deploy 50 times a day with automation, testing, and rollback strategies that protect the business. If you walk into an interview and confidently explain how code moves from the developer's laptop to production safely and consistently, you instantly stand out. This is the project that finally made me say, okay, I'm no longer thinking like a help desk tech, I'm thinking like a real cloud engineer. We start with a GitHub repository that contains your application code and automated testing. This alone proves you understand source control, something most entry-level candidates still struggle with. Next, we build a pipeline in AWS code pipeline that connects GitHub to code build for compiling and testing the app, code deploy for automated release into production, CloudWatch and application load balancing health checks for safe rollouts. Here's the complete workflow. Code commit, pipeline triggers, test run, deployment begins, health check passes, new version goes live. No manual action, no human error, no downtime. Next, we configure a rolling deployment strategy that updates instances gradually while keeping the application available. If health checks fail, automatic rollback. That is what hiring managers want to see. Automation, safety, repeatable, and real DevOps workflow. The moment CI/CD became real for me was during a deployment that went horribly wrong. The new version had a bug that would have taken the entire application down. But because we had a pipeline with health checks and automated rollback, the system caught the failure, reversed the deployment, and users never even noticed. Then I realized automation isn't optional, it's protection. Without CI/CD, the outage could have cost the company hundreds or even thousands of dollars and even someone's job. And when I told this exact story in interviews, it built instant trust. We wrapped this project by documenting the full pipeline architecture, the deployment workflow, rollback logic, screenshots of successful builds and deployments, links to logs, code, and diagrams. This shows hiring managers that you don't just build things, you communicate them like an engineer, which is half the job. Once you have this CI/CD project, you're no longer just someone who knows AWS. You're someone who understands how companies ship code, protect uptime, and deliver features fast. This project instantly tells employers that this candidate can operate in real engineering environments on day one. And I'm going to be honest with you. Having great projects means absolutely nothing if you don't know how to communicate the value. Most IT professionals spend dozens of hours building projects, then sabotage themselves in interviews because they present them like students instead of engineers. Your goal is not to explain what you've built. Your goal is to communicate business impact that proves you can solve problems that matter to organizations. On your resume, never write things like built a web application using AWS. That's a school assignment. Instead, you want to say architected a highly available AWS infrastructure handling 10,000 requests per hour using auto scaling, load balancing, reducing operational costs by 40% while maintaining 99% uptime. See the difference? One shows a task and the other shows competence, scale, and business value. Your GitHub must look like something a mid-level engineer would present. That means a clear project structure, architecture diagrams, screenshots of dashboards, pipelines, and monitoring, including a README file with deployment instructions, explanation of trade-offs and why you made certain design decisions. When a hiring manager sees clear documentation, they're going to think to themselves, this person communicates well and we can trust them to work on the team. Your LinkedIn must be optimized with the exact keywords recruiters are searching for as well. AWS, VPC, Terraform, CI/CD, EC2, load balancing, auto scaling, RDS, code pipeline, DevOps, and you need to post about everything you're learning. Recruiters reach out when they see evidence of growth, not just credentials. Here's exactly how I summarized Project 1 in interviews word for word. The business challenge was needing a highly available, scalable application that could handle traffic spikes without downtime. I designed a multi-AZ architecture using VPC, public and private subnets, an application load balancer, an auto scaling group with CPU-based policies. RDS handled persistent storage and multi-AZ mode. S3 served static assets, and CloudWatch provided monitoring with alarms tied to system health. The result was a cost-optimized, fault-tolerant environment capable of automatically scaling up during peak usage and scaling down during low demand, maintaining 99% uptime while reducing infrastructure costs by about 40%. When you present your project like that, the interview is essentially over. They already know you can do the job. Hiring managers will ask you questions like, why did you choose this architecture? How would you scale it to 1 million users? What went wrong and how did you fix it? Your answers don't need to be perfect. They just need to show clear reasoning and awareness of trade-offs. I'll give you a real example. In one of my early cloud interviews, the hiring manager asked me, walk me through something you built and something you're proud of. I walked them through the exact architecture you're learning here, the VPC, the application load balancing, auto scaling, the RDS. He didn't ask about my degree. He didn't ask about my certifications. He drilled into my decisions. And because I built everything myself, the answers flowed naturally. And by the end of the call, he said, we've interviewed people with more experience, but you understand the full picture. We want you on the team. And that's how I landed my first real cloud engineer role, because I could communicate engineering thinking, not just memorizing AWS terms. When you present your projects the right way, you stop looking like an entry-level candidate. You start looking like someone who can deliver impact from day one. This is exactly how my students land 120 to 150 cloud roles without prior cloud experience. It's not luck, it's presentation, clarity, and competence, demonstrating through the right projects. Build a scalable web application to prove you understand AWS fundamentals, automate that infrastructure using Terraform to show you can code infrastructure, and create a CI/CD pipeline to demonstrate you understand modern DevOps practices. These 3 projects will put you ahead of 90% of other candidates who only have certifications. You can keep collecting certifications like Pokemon cards, hoping someone finally notices your credentials, or you can build these 3 projects and prove you can actually do the job from day one. If you want to build these projects with our guidance and land a 120 to 150 cloud engineer role within 12 months, click the first link in the description, and I'll see you in the next video.